are federal agencies or ports, utilities, state agencies, associations, districts, and national labs. Next slide, please. So our agenda today will really focus on modeling results, the overview, and statewide planning next steps. But before that, we'll quickly do a project review and run through some project updates. Also, if you have any questions or comments, feel free to drop them in the chat or raise your hand. And with that, I'll pass it over to Watson to do a quick project review.
Yeah, hi everyone. Good morning. And just to remind everybody what the e-truck is it's this research hub to develop and deploy high power charging infrastructure. So focusing on the heavy duty vehicle market and there's a bunch of goals that we have around equity, workforce development, market needs and technology assessment, research and development, public order charging strategies, and we have a number of deliverables that are have been produced and are near completion there in these areas. So we're pretty excited on the progress and that's going on with the project there. So. Again, this is funded by the California Energy Commission, this project. So thank you to them. As on the next slide, we have a bit of what the TAC is about, and really appreciate everybody joining and taking an active role. And as we're going through these slides, raise your hand, interrupt us if you want to pause and get clarification on things. This is an advisory board, so again, we'd love to get your advice. Um, and so what this board is about guiding the project direction and making sure that through this committee and our ITAC and the WEDAC and community TAC that we're connecting with folks and listening. We want to you know we want you to be a sounding board. We want you to kind of help guide what this is. Share your knowledge of the applications and really make sure, but at the same time, we want to make sure it's a good use of your time and you find value in it. So if you need clarification on things or you want to guide things in a direction, please let us know, give us feedback. And so with that, I'll turn it over for the project updates.
Watson. So the Advanced Transportation Research Center, we had our grand opening and ribbon cutting last month in early May. It was a great turnout. So the lab's officially open. We have information on the press release. We have a refreshed website on the etruck.org website detailing the high level specifications of the lab. We're also working on uploading a more technical document that's going to cover the more technical lab capabilities. That's going to be being released this week. So yeah, we have links to the press release here as well as a link to the website I think is being placed in the chat at this moment. So please check it out. We are also in the middle of having early conversations with a couple applicants that are they're interested in utilizing the lab. So we're getting some traction on that end. And again, we're always looking to spread word of the availability of this lab that is open to the industry. And our goal here is to advance developing technologies that can advance heavy duty charging. So we encourage everyone to sort of spread the word, check out the website, and we encourage applications as well to utilize the test lab. And with that, I'll pass it on to Liz.
All right, thank you, Ken. So another major update for the e-truck project is that we have now finalized the modeling of charging infrastructure results for California for medium and heavy duty truck charging. So we have now kind of finalized the e-truck advisory committee feedback process. So we held 3 working groups in May based on kind of different stakeholder areas of expertise, and have kind of now incorporated the feedback that we have received through these working groups. One of them being that when we publish the HEMAP 2.0 on the e-truck website, we will also be publishing an accompanying technical memo, which will be describing the data processing and kind of modeling assumptions that went into the results. I think that was kind of one of the major questions that we had. And secondly, we would also be addressing kind of the shared and hybrid charging business model needs. Again, a big subject of conversation, right? Kind of these emerging hybrid charging needs in California. And so those will be addressed in the analysis portion in terms of the next steps here, which is HEMAP 3.0 and the statewide deployment plan. And so for next steps here, before publication on the e-truck website, so we now have received the final feedback from the CEC. And so we're working on incorporating this feedback. And once that's done, we will be ready to publish on the e-truck website. So please keep an eye out, and we'll make sure to inform the TAC when it's ready for publication. And then, so the next step here really is the now analysis of these modeling results, right? How do we make sense of these modeling results? And how do we translate these into a statewide deployment plan? And so that will be the main topic of discussion for today as well. But for now, I'll pass it on to Gia for the next round of updates.
Thank you, Liz. So hi everyone. So for anyone who is in or around the Anaheim area, a few of our e-truck team members will be at Angel Stadium tomorrow for the CalSTART and CARB Ride and Drive starting at 9 a.m. We'll be holding an in-person joint CTAC and WEDAC meeting, along with a tour of the Anaheim Transportation Network, which has opened its solar-powered EV charging hub, The Charge, that will provide charging for their fleet of 80 battery electric buses. So if you'd like to come meet fellow e-truck advisory committee members, drive some heavy duty trucks, and check out infrastructure in action, you can message me. I'll put my email in the chat or drop a message below and I can follow up with you. But yeah, that's tomorrow at Angel Stadium at 9 a.m.
All right, thank you, Jim. So this brings us to the main topic of discussion for today, which is kind of going through the next steps in terms of the e-truck final charging infrastructure deployment plan. So if we move on to the next slide. Just wanted to give a quick recap here in terms of the project process, in terms of modeling medium and heavy duty charging infrastructure needs in California. So the project team really met quite a few milestones in 2024 for modeling. So the first one here really was the publication of the fleet charging infrastructure needs and technology maturity assessment. So this was based on feedback collected from the freight industry. So kind of getting the fleet feedback, but also kind of from OEMs and EVSEs to understand kind of the timelines for technology maturity for high power charging in California. So those reports are now published on the e-truck website, and I think we may be able to send the links here too in the group chat. And secondly, we also worked alongside Cambridge Systematics to really understand freight travel patterns by distinct truck market segments in California. So we were, for example, looking at routes, dwell times, and hours of operations for specific kind of market segments, such as kind of drayage charging patterns or kind of truck operation patterns. We're looking at regional freight patterns and also long-haul freight patterns there. And so all of this data, was compiled based on real-time truck GPS data, but also expanded to represent the California as a whole. And this is one of the sections from the accompanying memo that will be published alongside HEMAP 2.0 to kind of explain some of the data expansion processes that went into the travel demand model. And so the next stage here really was to integrate this travel demand model into the Lawrence Berkeley National Labs heavy load model. You may have heard of this modeling, and it has been used previously in the statewide infrastructure assessment, the annual assessment AB 2127. And so in this case, we were using kind of the framework of the heavy load model in order to be able to have a look at a very kind of granular level. So we're looking at a 2-mile radius in order to be able to identify regions of high energy demand, for example, and looking at charging needs by specific market segments. And so this is what we're calling the HEMAP 2.0 deliverable, which is due to be published soon, so either in June or July. Which brings us here to the final 2 steps of the modeling of infrastructure needs, which is what we're calling the 3rd iteration of the HEMAP, so HEMAP 3.0, and also the statewide infrastructure plan. And so these 2 next steps really are to be able to utilize this kind of modeling data and these modeling results that we have kind of now presented in this map format in a way that can be translated into a statewide infrastructure plan, and being able to identify priority locations for charging in California. So if we move on to the next slide. Thanks, Gia. And so again, just to kind of give a context in terms of what are the main objectives of the final statewide infrastructure plan. So one of them being developing a sequential plan for future deployments of an advanced high-power public charging network. So again, just want to highlight here that the main areas of focus for the eTruck project really is a public infrastructure charging network, and we're also focusing on kind of advanced high-power technology that's currently being developed as we speak. And the second one here is to identify where the medium and heavy-duty charging infrastructure is needed to answer the projected kind of zero-emission truck energy needs. And so we're looking at 3 distinct years here, so 2027, so very near-term charging needs, 2030 and 2035. So the goal here is really to look at the next 10 years in terms of infrastructure needs for a public charging network in California. And thirdly here, another aim of the statewide infrastructure plan is to identify grid upgrades that are needed to build the above deployment plan. So we are looking at, as we speak, at grid capacity data that's available in California. And in terms of the outputs, again, these 2 were mentioned in the previous slides. So we will have HEMAP 3.0, which will be presenting these prioritized locations for public truck charging, looking at specific statewide transportation corridors in California, including power and energy requirements to support the truck volumes that were kind of modeled as part of the Cambridge Systematics efforts there. And again, also the report format, which will be the final statewide deployment plan, looking at infrastructure and equipment needs and installation timeframes for the identified priority sites that are presented in HEMAP 2.0. Again, as Watson mentioned, feel free to put your hand up or interrupt at any point in this presentation. If you have any questions, please feel free to do so. You don't have to wait till the end of the presentation section. Thanks, Gia. All right. So as mentioned before, we now have the charging infrastructure modeling results for California. And so the aim of this team is to translate these results and kind of make sense of the results in order to create a statewide infrastructure deployment plan. And so the project team have identified 4 focus areas to be able to kind of analyze the results. And this is what we will be going through today during this TAC presentation. And we will have a discussion portion also to be able to kind of get TAC feedback here on the current methodology that we're proposing, the current frameworks that we will be using, and if there's kind of any additional frameworks or resources that we should be integrating into the statewide infrastructure plan. So this first bullet point here, identifying priority corridors and transportation planning tools. So the aim here is really to be able to layer information over the modeling results from HEMAP 2.0. So for example, some of the data sources we've kind of are currently identifying are priority freight corridors. So we're looking at, for example, SB 671, looking at the identified disadvantaged community areas in California, and also looking at grid capacity data. So at this point in time, just compiling all of these resources and being able to translate them into map format and layering them over the modeling results. And we do have some kind of initial layering that we'll be able to show in some of the next slides as well. And secondly, as was mentioned in the previous slide, we are looking at a 10-year range for modeling charging infrastructure. So in order to be able to analyze these results, we are kind of implementing the phased-in approach using the federal zero-emission corridor strategy as a kind of framework there, as the timelines that they're using for the corridor strategy match very well with the years that we have modeled at this point in time, which is 2027, 2030, and 2035. And again, we do have some preliminary maps there with this phasing approach that I'll be showing later on. Thirdly here, so one of the challenges that we have kind of started seeing with analyzing the results is that certain areas, especially these kind of phase one hubs, so we're looking at, for example, the Los Angeles area, the San Diego area, San Francisco, Sacramento, we're seeing a lot of energy consumption and a lot of charging needs pretty much across the map. And so in order to make sense of this data, we kind of need to aggregate all of those low energy hexes and also assign them to specific kind of priority road segments as identified with the priority freight corridors from some of the other layers. And again, I'll be able to go into more detail in the following slides. And the fourth one here, so again, one of the data sources that we have been collecting as part of the eTrail project is all of the currently opened medium and heavy duty charging stations, public and kind of semi-public in California, as well as looking at where the stations are currently being planned and kind of in the construction phases in California, and able to then overlap this information with where we are seeing kind of high infrastructure needs in California, and kind of starting to identify where there are certain gaps where we're not seeing any infrastructure currently being developed, even though we know that there will be a near-term need for charging infrastructure in this area as we're looking at 2027, which is only a couple of years away. Again, I'm just going to do a few pauses on each slide if there's any questions. I see Watson's hand is up.
Yeah, Liz, I was just going to pause also, because while the modeling effort was really valuable and important, the modeling alone doesn't create a plan, and so what Liz is talking about here is how do we connect that modeling data to put it into tools and resources and information that can be used by people, and so that's really what we're trying to do now with a lot of this work is help translate that this modeling data that's really helpful and valuable, and to how we connect it to the corridors and the can we learn from that data, phasing in of things and things like that. And so this is the area like we really need your guidance on, because because how do we turn this information, data into information. So thanks, Liz, for working with us on that. And I see Leslie's got her hand raised.
Yeah. Did you want to say something first, Elizabeth?
No, go ahead.
Yeah. So I just got to preface this by saying, first of all, thank you so much to the EPRI team for giving a couple folks on my team a little bit of a 1-hour session on the truck side of megawatt charging, because I've been real curious to see what's happening on that, because that's going to be the demand for this solution. I was on the lower part of the learning curve. I'm a little higher up now, feeling pretty good about that. What they let me know is that the current Class 8 trucks out there that are charging at, the 250, 350 kilowatt chargers have an 800 volt battery architecture. That is not going to work with megawatt charging because then it requires a lot of amps, high current, which means a lot of cooling. So what is needed to be able to successfully use a megawatt charging is a battery architecture in the 1,000 to 1,200 volt range architecture. Right now, Tesla is at 1,000 volts for their charging, which they do at 750 kilowatts. So what maybe just explain, or maybe I could just introduce this part of the conversation. If there's going to be a build out of this corridor, is there a follow along with the truck OEMs to, start, creating the trucks with, the 1,000 to 12 volt battery architecture to utilize this. And let's see, what was my second question? This is another one, technical question, of course, very low on the learning curve. Is it possible for those the higher volt architecture trucks to comfortably use the lower kilowatt chargers, the 350? Like, does the reverse work? I know you can't charge an 800 volt battery architecture at a megawatt, but can you charge a 1,200 volt battery architecture on a 350 kilowatt charger? So complicated question, but it's the mismatch that I'm hoping that it gets integrated into this conversation.
Yeah, no, that's great. Yeah, thanks, Leslie. Yeah, can the can the higher power trucks charge at the lower voltage or lower power infrastructure, the legacy infrastructure, and there's just a little bit of an add-on that the truck folks will have to do to make sure that it has that backwards capability, and it's kind of not too dissimilar to what Hyundai and Porsche do with their higher power charging, and making that backward compatible. So there is a pathway there. You just have to, acknowledge it from the front to make the backward capability. If you look at our planning, that it's all around, when you look at the heat map modeling and stuff. We have the infrastructure. There's a good amount of 350 kW chargers and some of the near megawatt level chargers that are in the planning approach. So we don't have in our planning thing, we don't have the multi-megawatt power level charging in our planning assumptions there. We just have the near megawatt, which is kind of where the state of the most capable vehicles are today, is in that near megawatt zone.
Yeah. So, Watson, I have my hand up, if you can see.
Oh yeah. Oh, go ahead, Ted. Yeah.
I just want to say that we're addressing this in J3400/1 and J3271 on adapters. And so adapters might not, in fact, be a cable, but a box that has the power converters built into it as well, such that you can do backward compatibility to legacy stations. A lot of people say, just keep investing money. Come rip out the old, put in the new, and just keep using the new. But like, I don't know what, payphones and other stuff, there's going to be a certain amount of infrastructure you can't afford to replace. And so the technical part that Leslie was just saying, can this be done? Yes. Right. Will this be done safely? That's where the standards come in. But the whole idea is, if you have an X station that is just fine, but underutilized, and you can get a medium duty, heavy duty vehicle in there, should you be allowed to charge an MCS vehicle off of a CCS resource? The answer is yes, right? Especially if it's a 600 amp cord. 600 amp is just fine. 600 amp will not challenge the 3000 amp inlet, And so in that case, the small into big is something to think about. That's actually the easy question. But the answer is roadmap is set. Technical things are on the horizon. There's a lot of pushback. People say just don't, right? No swimming at this beach ever, right? There'll be people go swimming, right? And in the case of no trucks allowed here, if it's a commercial site and your money is good, they're going to pull a truck into that spot. And again, some of the new trucks, many of the trucks will have a MCS and a CCS inlet, and then you just choose whichever one is the flavor that of the station you pull into, right? And that's what's going on at EVS 38 this week. J3271 and IEC and Charan have a committee to look at multi-inlet safety, such that if you have 3 different inlets on your truck, how do you make sure that they all get used safely? So just to kind of layer in there, a lot of people are doing a lot of work on this, and right now concurrently in Sweden, there are people showing this stuff off.
Thank you. Is there anything happening in California with the EV? Where's EVS?
Close. So Watt EV, just as far as like who's got skin in the game, Watt EV has stuff at Bakersfield and
Yeah.
San Bernardino, but it's a work in progress. And
Yeah.
the same and again, Portland is not California, but again, just up the road, the
Yeah.
Electric Island has always had the intent of swapping in new stuff and use that as a roadmap. And then most of the stuff at the expo is all pointing towards 2026, 2027 planning. So they're getting the permits today, but 27 is when it's going to be turned on.
And then on the truck side, where do you think that's
truck is something happened in Washington. I'm not sure what it was, but some people don't want to spend money on electric trucks for some reason.
Yeah. Okay. Thank you.
So as soon as those orders get unjammed, as soon as somebody gets the plunger out and unjams that clog, like eVTOL's got a huge bump because the White House said eVTOLs are good. And it's like, so we need the same thing happen with the trucking industry. And maybe the people who pulled that thing on the migrant farm workers are okay. We need to have the electric trucks are okay. Lobbyist. Yeah, just to paraphrase, everybody's pushed stuff back into 2026, 27 after the next, change in Congress, maybe. Whatever someone's optimism is, but just financially, no one's stuffing money into electric trucks right now. Even Tesla's been pushing way back, right? They just, as much as they said, 100 trucks this year, I don't think they're getting 100 trucks out this year.
Great. Thanks for that, Ted.
And Ted, is Tesla using the newest MC?
And that's the multi-inlet thing I'm wondering about. It's like, are they going to have an adapter? Are they going to have? And I've been telling people like a Yeti cooler. Is there going to be a little thing with a handle, right? That's got this connector in and then a pigtail MCS out. Is that the widget that you're going to use? I don't know, but it's going to be small. I'm not sure it's going to be softball small, watermelon small, or Yeti cooler small. But there's going to be some way that they get the 2026 truck fleet ready for 2027 to 2030 infrastructure. Meaning that Tesla on their slide has like 300 stalls by 2027. It's like, well, that's kind of a very slim sliver, right, across the Southwest and Atlanta, and then like a very small corridor in Chicago. Then what? What do you do when you leave that area? And again, I think the answer is you only use MCS, you only use CCS trucks or this adapter or the multi-inlet thing. But again, seeing that Tesla vehicles in other countries have used combo connectors, it may be that the truck uses a combo. I don't know. It just doesn't seem to me like the NACS on a commercial vehicle is going to go, but maybe that's what's coming. Because again, they're 600-700 amp is going to be just fine, right? So people say, I can't get by with only just say 300 kilowatt. I think 300 kilowatt is going to be just fine.
Yeah, and that 300 kilowatt is plenty for the dredge trucks and
that's what I'm saying. There's a lot of markets that 300 will get you through the day, and it doesn't disrupt the schedule. You want the future, and that's basically what's going on today, or what was today in Europe with Scania and MAN, their air quotes only push 1,000 amps. So for their 700-volt battery, that's only 700 kilowatt. So, and then if you just cut that in half and we're double the time, you'd say, well, then 500 amp is just fine. And that's why we see so many CCS fleets just saying we're going to stick with this for a while. And just for the good of the group, there's a lot of manufacturers have been pushing the envelope that they think they can run 800 amps continuous on a CCS connector. And so that starts to kind of creep into the bottom end of the, well, I have to jump another tier or whatever, a non quantum, right? I have to move up a quantum into the MCS world. People think that they can just keep stretching, like nitrous or supercharging. They can just get more out of what they already have with cooling, right? Again, the key, you say, well, how does this trick work? It's same amount of loss, or put it this way, it's more loss, more cooling. And so that's how they manage the temperature to run so much more. 400 amps used to be a lot. And now, everybody's 600 amps seems to be the norm, and 800 amps seems to be people who, again, big heat exchangers, a lot of pumps. One person said that cable feels like a overstuffed sausage when it's running full flow. Like the cable gets really stiff because they're running so much flow through it.
Yeah.
Anyway, sorry again, it's just that's what's going on in the world today. Like I said, at EVS, there's a whole bunch of new things being announced.
Yeah. So this is one of those areas where physics matters, kind of like at the end of the day, the math matters of power and how you deliver
or
it.
the whole,
So
you be careful what you wish for. I wish I could run 800 amps in the cable. Well, that cable's going to be really fat. It's going to be really hot. And one of the things I'm just realizing at these pressures to get this kind of flow, that thing's going to be like a really rigid sausage.
thank you. Yeah, hey, Liz, you can.
Great. No, great conversation. Thank you. All right. So, kind of continuing with the conversation around the methodology that has been used. So again, sorry, I see another hand up. Go ahead, Mary.
Yeah, hi, this is Mary Brazel from the Oregon Department of Transportation. And I just want to be clear, when you're talking about the modeling, when you're saying you're using, I think, 300 or 350 kilowatts, uh, as well as near megawatt, what exactly are you, what exactly is the near megawatt consisting of in your modeling and in your assumption that these stations will have?
Yeah, great question. So the charging levels that we're using in the modeling are, so I think it starts at 150 kilowatts for medium and heavy duty charging, and then it goes to 350, and then it goes, I think, is there something 500? Or I think it may jump straight to 750 kilowatts. So that's what we're calling near megawatts. And as we're looking, for the next 10 years, it goes all the way up to 1.5 megawatts in the modeling. So there's 350, 750, 1,000, 1,500 kilowatts.
So those higher power levels are coming, but yes,
Yeah,
I think
I guess
this. Yeah.
what I'm trying to understand between what Theodore from ANL just said and what your modeling is saying is I mean, if we're trying to build public charging stations along interstates going from California all the way up to through Oregon to Washington, kind of for the public charging for the next 5 to 10 years, 5 years at least, you know, do we need to go to the megawatt or do we need to go to the near megawatt? Is the 750 what
Well,
is likely to be used?
again, the turnaround time is the big thing, that if you can get the vehicle on the driver's brake back out on the road, I think that's the objective. And so megawatt gets you there quicker. But there's a show called The Electric Trucker in Europe, and it's a guy who basically, quit his job in an office and drives an electric truck. He makes episodes. He said, "Here's how I do my job." here's how I do my breaks. And everything points to the 2, 3, and 400 kilowatt and nothing more, because there is nothing more in Europe. But he drives all around Spain, Germany, England. And he said, here's how I plan my stops. Here's how I get my truck underneath this awning. And again, all that stuff could be here if we had a market that supported electric truck freight. But that whole 5-year thing, you're exactly right. 200 is the minimum, 300 is desirable, 400 seems to be where a lot of stations are going. 5, 6, 7, 800 are wishful thinking if you can afford it. And again, that's where the corridor basically just said, let's plan for 1,000 amps, but we don't have to require 1,000 amps.
Thank you. I'll let you keep going, but I may want to follow up with you all a little bit later. Thank you.
Thanks. And actually, in one of the upcoming slides, we are kind of going to be showing that some charging profiles, for example, drayage and regional, we are looking at more towards, especially phase 1, which is the near-term 350 maximum. We're not looking really about that, but we'll get to that in a few minutes. But yeah, I think maybe this one we can skim quite fast on it. It's just basically presenting some of the layers of information that we're overlaying on the modeling results. So one of them being the state level priority corridors from the SB 671. I think we also have a link to that report that can be shared in the chat here and also in the notes once shared. Sorry, Watson, did you want to add anything?
Oh, no, it must have been background noise. Sorry.
No worries. So yeah, maybe if we move on to the next slide. This is really kind of going into what we're at this point in time mostly focused on, which is the federal zero emission corridor strategy. And again, I think we have a link that we can share here in the chat if you're interested in kind of reviewing the report yourself as well. Thanks, Lisa. So I think the reason why we're really focusing on this federal corridor strategy is because the timelines coincide very much alike the modeling timelines that we've selected, which is 2027, 2030, and 2035. And as you can see, as we're building a 10-year plan, having these kind of phased-in approach, focus, for example, here in phase 1 on establishing the hubs based on the kind of early adopters. So in our assumptions, the early adopters are the drayage and regional delivery market segments here. We're able to kind of prioritize a charging network that would kind of allow those segments to be able to operate kind of electric trucks. Also, just a reminder that we're focusing on a public charging network, right? So we're trying to identify within those specific market segments which are the trucks that are going to be needing a public network to supplement, for example, any depot or private charging that they also have available. So we're looking, for example, at opportunity charging throughout the day in phase 1 here. So that's kind of starting now to 2027. Again, we are also monitoring all of the charging stations that are currently being opened in California within that time frame. So being able to then conduct a gap analysis of what are the near-term needs for a public charging network and what is currently being kind of developed in California. And so one of the other reasons why we're kind of selecting this zero emission freight corridor strategy is because we're also able to then leverage kind of all of the policies that are currently kind of in place for the near term. So looking at funding opportunities in California and what kind of priority corridors those opportunities are kind of focusing on as we speak. Phase 2 here, which is 2027 to 2030. So the next stage really is kind of then connecting the hubs that have been identified in phase 1. So we're looking at some of the mustard colored road segments here on the second map. And again, here now we're starting to go into territory of long haul. So how do we kind of create a public charging network that would allow long haul trucks to connect, for example, from the port of LA or the port of Long Beach and going into the inland empire here, the San Joaquin Valley, and then potentially connecting, to different states also, looking at, Oregon, looking at Las Vegas is one of those routes that we're looking at as well. And again, the third phase, looking at more long-term, again, enabling interstate kind of freight corridor activity here, and just kind of expanding the network. And if there's no
Hey,
questions.
Liz, could you remind folks of what the dots are on there?
Yes, so those are intermodal freight facilities that have been identified as part of the federal corridor strategy. So we're looking at ports, airports, railroads, and then potentially truck stops in those areas as well. All right, moving on to the next slide. So here's one of the slides, Mary, that I was referring to. So again, we're looking at the kind of the phasing approach right here. I'm focusing on the hub, which is kind of the LA County region. And again, looking at kind of the early adoption needs, so looking at 2027. So in this case here, what I'm presenting on the screen is just kind of isolating drayage charger needs for 2027. And so this is kind of, starting to create a pattern here. Also, as we can see on the right-hand side, in the modeling, we're assuming that about 70% of drayage trucks will be reliant on kind of public charging here. And here we also have kind of the charger power level selection of these trucks that have been modeled for 2027. And as you can see, we're mostly kind of staying in the 350 kilowatt territory for the opportunity charging, and then also kind of lower power charging, 150 kilowatts for overnight charging, for example. And then we can also start seeing the kind of hours of day for kind of when the drayage trucks are mostly charging. As you can see, it's mostly kind of overnight charging, and then kind of at the beginning and end of the shifts there. So again, I can pause here if we want to have it, allow the team to review the.
Yeah, no, and all the depot charging may not be that, the longer overnight. We have talked to some of the drayage operators that expect the trucks to sip, so to speak, at the infrastructure, each one of their trips while they're loading and unloading the goods there. So some drayage operators are taking the SIP approach, which is, while the truck's there for the 15 minutes, they're going to always try and fill the battery so that it doesn't have to have a long duration overnight charge, so that they can continue to maintain a state of charge in the truck. So we expect to see some different behaviors in the depot charging, not just the long overnight thing.
Thanks, Watson. And if we move on to the next slide, I have another charging profile, which is regional delivery. Thank you. Again, looking at 2027, the Los Angeles County area. Again, we can see here 50% or 51% reliance on a public charging network, mostly focused on the 150 and 350 kilowatts charger power levels here. And again, as we can see, in terms of the energy consumption by hour of day, we're seeing most of the charging needs happening overnight or at the end of the shift. Right, moving on to the next slide. So again, this is just an initial layering of those priority phasing corridors from the zero emission freight corridor strategy onto our infrastructure modeling map. And as you can see, when we're looking at it at a statewide level, there is a good match in between the modeled results and the kind of major corridors that we're seeing. Again, a few outliers here. We're seeing a few routes that haven't kind of been captured by the priority corridors. But then if we look on the left-hand side, so this is the LA County area, it starts getting a little bit more, what's the word, muddled. So we can see kind of some of those priority routes there that are following the blue lines that are at this point in time laid underneath the modeling results. So it may be a little tricky to read these, but kind of the overall highlight here or emphasis is that we're seeing energy consumption kind of throughout the area. including in kind of residential neighborhoods. And so the yellow here is representing kind of lower energy consumptions, and the red and purple are representing higher kind of energy consumptions here, kind of daily energy consumption. So the next stage here really is to be able to kind of aggregate all of those yellow hexes to specific priority road segments that again follow those priority corridors as identified by the Federal Corridor Strategy. Thanks, Gia. And so this is the last slide of the presentation before we can go into the discussion section. Again, we can always go back to a slide if there's a question that arises later. So this is an initial gap analysis of one of the hubs that were identified for 2027, which again is the LA County region. So we are working closely here with our partner SCAG, as this is kind of one of their main catchment area. So I think we have Jonathan Rasper here on the call as well. So Jonathan's seen this map already. So this is kind of the gap analysis showing where we're seeing our model charging needs, kind of stations being built. So it would be those red icons and those green icons on the map here, and then just kind of identifying areas of kind of high energy consumption where we are not currently seeing any stations being built. So I may have do I have maybe Wi-Fi issues? Is that what I'm seeing?
We can hear you, Liz.
Okay, thank you. Right,
All
perfect.
right.
Okay, I'll pass it on to
Great.
Marcel.
Yeah. Yeah, great. So like when we look at, like that last slide that Liz was sharing there with the all the charging needs there, and with the purple were the highest density of charging needs, and we were with corridor strategies, you're aligning those charging needs with the corridors, and it becomes a bit more complex in LA because the density of all those corridors is so high. Um, and so what the team was trying to do was to based on the planned infrastructure to identify those where those gaps were. And so I think, going back to the questions there, if you don't mind going back to the question part there of is there any kind of criteria that can help us, identify these ideal network charging designs? Like, just to see kind of ideas for, people's reactions of like, is should the infrastructure be set up for people to sip and maybe not fully recharge, but have high availability, continue to sip and to replenish the energy that was used frequently, or should there be more of these bigger hubs that require higher power charging and longer, potentially longer duration charging? So, that's the kind of thing we're looking for, kind of reaction to, is what are people hearing, from fleets? What are the reactions of what's the market asking for, and so that's kind of the point of this first question. And John, I see your hands up, but yeah, feel free to jump in there, John.
Yeah, thanks, Watson and Liz and all. This is John Mitchell, EOCPA, just trying to put the pieces together, listening intently for the briefing that's been given. So thank you guys for all the work as always and keeping us all up to date. Just looking at this first question and trying to piece together what we've all heard over the last few minutes. Um, one thing that I didn't hear a lot about is distribution circuit capacity as a layer of understanding for projected demand at a site. Certainly indicates that there's a faster path to business case sustainability. But the question is how soon can that site be delivered if there is in fact projected high demand there? Because a corridor is a corridor, but a corridor is just a series of projects that gets done to enact, accessibility of charging along a corridor. So without an understanding of what individual projects can be built in a reasonable time frame, and that those projects will likely result in high demand and throughput so that the site host actually is getting a return on their investment, it's really hard to look at things at a macro scale if you don't have an understanding of how easily it might be for the property owner or the prospective site host to actually build a project there. And I think in the LA basin, we see that very acutely with many of the projects that we're already deploying in that region of California. And so one request that I would make of the analysis team is as you're looking to phase three for site prioritization, that you look not only at what the heat map says in terms of prospective demand at a site, but also what the available data from PUC might say in terms of energization availability and timeline. And then on top of that, perhaps doing a site assessment of access and egress at the site, maybe using a tool as simple as Google Maps to see, what is the current built condition for that particular site to see if there is appropriate access and egress for a pull-through configuration for a Class 8 truck, because I think many of us who've done projects in this space understand that pull-through is the optimal configuration. And if you aren't able to deliver pull-through, unhitching and having to charge, adds time, adds cost, all those considerations. So I try to think of it not only from the fleet perspective, but also from the EVSP perspective, and then also the energization perspective, because the quicker we can get these projects done, the quicker they can make money, the quicker we can replicate them and show that the market is real with or without subsidies from the government. And as somebody who works for a funding agency in this space, and the prospectus about our capacity to fund projects like this very much uncertain moving forward, in my mind, what makes this guidance most actionable is if it allows private sector entities to decide how to move forward with their own resources unilaterally in the most expeditious way possible. So I just wanted to share those kind of thoughts and insights as you guys are asking questions about criteria for ideal charging network design. Those are some of the characteristics that I think would lead to the best and most viable near-term outcomes.
That's great. That's great. And we didn't share some of that information that we're starting to work on the capacity available capacity integration. But yeah, there's work coming on for that. So appreciate that. Um, and I may want to talk about that a little bit more, but Jonathan, I'll let you chime in.
Thanks, Watson. Actually, this kind of tacks on nicely to the last comment. We've been talking with Jonathan Raspa from SCAG, and we've been talking to a lot of fleets and private operators about what their challenges are, one-on-one conversations, sort of not just in Southern California, but kind of everyone who's building this stuff out. We've had a lot of opportunities to talk to a lot of national fleets who are looking at this as sort of a broader, kind of longer term sort of switch over and also the sets of problems to be solved. And for them, delivery is really all over the place. And very often, sort of the distribution circuit capacity is just one of the many challenges they face. A lot of them are just not used to dealing with public utilities, kind of this different type of site development. It's much more involved and complex than when they're standing up a typical depot where they just need the space, maybe some fueling capacity, some office, not really a lot there. They are also dealing with a lot of construction delays. We've got a really tight labor market, and a lot of them are just dealing with the fact that they can't get the folks that are trained to do this to their site quickly enough, or if they have, sort of one item that's delayed, it kind of spills back into the rest of their construction schedule. They've found that permits are rarely the issue. It's often cited, but usually they're finding that local jurisdictions are getting more on top of this. And the business case, one thing that's really tough for them is that the electricity is just still really expensive in Southern California. And so to make this work, one thing they're talking about is trying to get a special rate, just for these truck charging sites that are using huge amounts of capacity or huge amounts of electricity, but are sort of accelerating this zero emission um, conversion. And then kind of the last thing is just a sort of consistent stream of funding. Most of them, they appreciate the incentives. They know that this is not like a net positive thing yet. It's more of a response to their own customers' demand, right? The different carriers are really just responding to their customers wanting to commit on their sort of clean energy commitments. Um, but the ones who are really building these sites out, they're not building public networks. The ones who have the most experience, they're really building behind the fence depots and sort of testing this out. And so for them, it's more a question of like, does this make business sense, over the next 5, 10 years? And they're not really trying to be as dependent on the public funding, right? Because as we can see, just over the last, less than 6 months, the availability of public funding has kind of, been in question at a lot of different levels, right? At the federal level, at the state level, and even some local incentives that are, maybe not as available as they were last year, and their future availability is uncertain. So they're sort of building this, I think, with the assumption that over the long term, they don't want to be dependent on public funding either. Having it available sort of lets them do these things a little bit quicker, limits capital investment, but over the long term, they don't want that to be part of the kind of overall business case internally that they make when they start to pitch to build these out. So that's just kind of a response to that last one. I know that went along a long while. I'd say the other question with number two, having one or two chargers versus a large deployment, I would say having those small locations scattered throughout the region is great. I think one of the things that comes up though is it's not just the land availability for those chargers, but also the additional waiting space. If these are in areas of high demand, even if they're, MCS chargers, you're going to get trucks that are waiting. They're very often not permitted to wait on the street, or there's just sort of limited space on the street that they can make use of. Local jurisdictions also don't like having trucks parked all over the place. And so we'd have to think about, even if it's a one or two or three charger site, it's going to need a lot more space for queuing. Again, not just site access, right? This isn't a drive-through, so to speak. More like them coming on site, sort of getting in line for that charger on site as opposed to off street, as opposed to on the street. So just something to think about. The land size availability is going to require more than just, where are the trucks actually sitting and charging.
Thanks, Jonathan. Hey, Jimmy, I see you have your hand raised.
Yeah. Hey, everyone. Jimmy O'Day at Caltrans. Yeah, thanks for this great discussion. And I'm going to have to jump in a few minutes to another call. But to build off, I guess, Jonathan's point, I agree that the space issues is a challenge. We're familiar with an operating charging site in Southern California that was designed for bobtail. And, of course, the trucks are coming with trailers and they're, dumping the trailers on the side of the road while they, charge. And that's becoming an issue, space. So, sites don't necessarily have to be designed for pull through. I mean, trucks, with trailers pull in and back into sites all the time at warehouses and whatnot. But the space should, I would say, largely be designed to accommodate a trailer as well. In many cases, as maybe as a best practice. The question of one or two chargers per site, to me, one or two chargers doesn't meet industry needs in terms of resiliency and just guarantee, even where the market is today. A charger being occupied is pretty easy if there's only one or two chargers. In our tri-state award with Oregon and Washington, we're setting a minimum of 8 ports per site and 2.5 megawatt site energization. And the developers are, up to them, how they want to meet that 2.5 megawatts, whether it's, 10 by 250 or whatnot. But we think, yeah, for sure, more than two. We're setting a target of 8 for our sites. Number three, what investment policies? I mean, yeah, you have all the right folks on this call. with, great programs at the Energy Commission, Critical Paths, the CTC's Trade Core Enhancement Program. I'll flag for folks that 2 Fridays ago, staff recommendations came out for the cycle 4 of that program. CTC staff recommended $94 million in ZEV truck infrastructure projects. 70 million of that is coming to Cal or would come to Caltrans projects if approved. And that 70 million for Caltrans projects consists of 6 projects, 13 sites across the state, ranging from 300 kilowatt ports is on the low end, up to over a megawatt. So we're not seeing in our proposals below the 300 kilowatt from what we got in our project proposals. Other questions? I think that's it. I'll drop a link to those staff recommendations if folks aren't aware of those. A really big investment that we hope gets approved by the CTC later this month.
Oh, that's great. Great. And I think the basis behind these questions is really that size matters, and the example I'll give for the utility impact kind of thing is this is an anecdote is if you go to the local pizza shop and say I want one pizza, they'll tell you it'll be ready in 25 minutes or so. If you go to that pizza shop and say you need 75 of them or 100 pizzas, they're going to look at you crazy and say, "Why didn't you tell me earlier?" You're like, "Yeah, I needed to know." Well, that's kind of what happens with the size of infrastructure we're talking about here. Is this like is this discussion has to happen earlier, given the size of what it is, and like if the prime objective of the infrastructure was to minimize the impact on the utility grid, you'd probably one of the things you may attempt to do is not the only way you would do it, but one of the ways you may attempt to do it is have smaller sites more dispersed because then you don't have the 100 pizza order, and so it makes that easier. But that if you take the perspective of a developer and they're trying to manage resources, the developer is going to say, like, yeah, I can't manage, that many sites. I want to find the need and develop a few sites and make those happen and get great focus on the fewer number of sites, and the fleets just need to serve their charging needs. So it's this balance of how do you address those different perspectives of what each folks are asking for, that ultimately to serve that need of supporting these fleets there. So I don't know if there's any more other questions of folks or comments on some of the policies, or how do we account for proposed stations in our plan there? Should we assess a likelihood that they're happening, or things like that? So I see John's raised his hand. Hey, John.
Yeah, just to answer your question and just to kind of put a finer point on one of the threads you and Jimmy were just talking about, and why I keep coming back to this is if a site needs a new substation in order to energize the site, you're talking about a 9-year lead time to deliver a new substation that's going to enable like megawatt scale charging. Or if there's insufficient capacity, like near the ports of LA and Long Beach, you're talking nearly a decade before you can actually build and commission trucks at that site. So that's why, I talk about near-term actionable information. If your goals are 2027, 2033, 2035, if you're wanting to deploy a station in 2035 that is a high power station from a truck charging perspective, you need to start buying the land and doing engineering for that site today. So if you're not doing it today, you're probably not going to get it done by 2035. So just to kind of put a point on that, if you need a substation upgrade, you're looking at probably more like 4 years, maybe 5 in some cases. So I just want to measure expectations about what's realistic in terms of deploying this technology at scale. and make sure that we find the sites that we actually can do sooner and prioritize research and interest. Um, and in terms of that last question you posed, Watson, on proposed sites, and I heard Geo say something about like at the event tomorrow that there's going to be a site selection survey. And so to the extent that you can have individual site hosts identify themselves as wanting to help deploy a project, I think that's where you're going to find coalitions of the willing that actually help to build this plan into a reality. So I think the combination of analysis that you guys are obviously doing a really good job on, but then outreach and finding individual champions to actually deliver some of the projects that the plan shows would be valuable for building out the corridor, for building out fleet access to public opportunity charging for those fleets that don't have behind the fence depot. I think is really one of those areas where, how the deployment plan would characterize those proposed stations. That might be a complementary strategy, and hopefully tomorrow's event will lead you closer up down that path, and events like it.
Thank you. Thank you. That's good. Good. Hey, Catherine, I see your hand raised.
Yes, thank you. Incredible analysis. Very impressive. Thank you very much for this. And I know that one of your questions on here, number two, was, do you want one or two chargers at each site? And this kind of made me think about before I came to the California Air Resources Board, and I was a design engineer, and we were talking about how important it is, when I was doing design to have redundancy. And so I do know that sometimes we hear of chargers being down, not being operational. And so I think that's something that you want to consider when you're looking at question number two. What is the likelihood of one of the chargers going down? Is there a part that maybe need to be replaced more frequently than others? Then maybe instead of having two chargers at a site, maybe you have a good stockpile of the equipment that needs to be done. I don't know also if it's like a logistics thing where you need to, find a licensed electrician and get them out there to do the work. But those were some thoughts that came to mind when I was reading that question.
Yeah, no, thank you. Yeah, and that's kind of exactly what happened in the light duty vehicle space for DC fast charging, which is some of the folks put in one or two, and if there was any reliability issues with the one or two, then the whole site was inoperable, and so as people move to larger numbers, it the availability to charge, increased, and yeah, no, done very good. Hey, do you mind if we go back for a slide to just explain why we're asking number two? So if you see some of those, while there's a muted colors that are the depot charging, there's the purple are the en route stuff, or the brighter colors are the en route stuff, and the highest number of charging sessions are those purple locations. But some of those, I'm sorry, I don't know the right color for it. Maybe it's mustard, those mustard colored sites that are shown there. There's only what the modeling produces results for just a few chargers at those locations. And so this is kind of why we're asking that question of like, oh, how do we, do we just draw a bigger circle and say, um, you know, we group them together, aggregate some of those things into larger um, um, needs there, and so that's the basis behind that question, because some of those, the mustard color sites are just have a few chargers. All right, and go back to the um. So the proposed stations, also when we look at that site, we kind of circled some areas that we thought would be good to highlight as the next step. But if some of those stations that were proposed that might actually have some significant charging needs don't move forward, I guess we will have to keep monitoring those in our plans. But I don't know if anybody's um, has some ideas on how we talk about those um, if you look at like that Ontario area where there might be a lot of chargers planned, but there's also a lot of charging needs, and so there is an interest in making sure that those things move forward, because that does serve a market need. Um, and should we be doing something in our plans to um, talk about those in a different way than those areas that we highlighted that appear to be underserved by planned? Jonathan?
This is just, we're talking about a gap analysis, and in
Yeah.
some cases, the inability to maybe develop these sites given like the really long timelines. We talked to two of the major package carriers about 2 weeks ago, and they were actually in the same room, so it was interesting they were this honest about it. But they said in a lot of cases for their early charger developments, and this is not, all long haul, but they do have a fair number of heavy duty trucks and then really large fleets of medium duty trucks, where they ended up really oversizing their sites for what was ultimately local distribution, which is what we're looking at in the near term, is drayage and then sort of trucks
Mm.
operating within some of these regions. And for them, it's starting to reach the point where they're sort of it's looking like a bad investment, not because, the trucks aren't less expensive to operate, or anything like that. TCO is lower, when you take into account incentives, but that the investment is just sitting there. These chargers that they built out, they're not getting used continuously. Um, and they're starting to entertain the ideas of looking for partners, kind of like some of these, charging sites as a service, like Forum and um, Zeem, where it might help to also identify in the plan as a bridge solution to like kind of lay out a framework for these. I wouldn't necessarily call it a public-private partnership, but to kind of make the case that, some of these sites that are underutilized, either because they're just, not needed as they're not as they're bigger than they needed to be, or maybe the fleet isn't as large as folks originally planned for a particular site that was developed. Um, to set up a sort of shared system, right? Where at least if people have trucks and they don't have charging sites yet, that, it kind of lays out a way where this can be incentivized to get some of these larger depots to share their sites to a degree. And I know there's a lot of, sort of questions and barriers to it, but it might just help kind of open up use of the trucks a little bit more, which is the ultimate goal of this, to get these trucks on the road, not have them sitting there or not being delivered. Um, and maybe there's a way, like, some sort of like state tax or other local policy that allows them to write off the value of that partnership to, like whatever the charging costs, or they can, write off a portion of the equipment costs, whatever it is, so that again, it just kind of gets more people using it, gets more trucks out on the road. I don't know exactly what shape that would take, but it was something that I didn't expect to hear from industry, but they were saying, it's actually ending up being the case for some of these charging depots they've.
Yeah, no, that's a good insight because eh, when you think about uh, I heard some similar thing kind of from a little bit of a different perspective around just this notion that there's going to be this contracted infrastructure because um, you know, Fleet A, may be interested in getting some vehicles, and they may have like you talked about the timelines and the cost benefit and the payback for the infrastructure in their site, and they may not have enough utilization, and so there may be also a need for them to contract because um, this on-route infrastructure, I'll just call it just, infrastructure that's going to be used during the daytime. Um, it's going to have to be secure. I don't say secured by contracts, but it's kind of different than us, pulling into a gas station and we see who's got the best prices that day, and you look and select that way. With the trucks, they have a job to be done, and so they're going to have the infrastructure secured and available, and um, for their daily routes, and so I you know for a number of angles, I do believe that there's going to be a lot of contracted infrastructure where people buy a share, is essentially buy a share, or buy some, a time slot or whatever it is to use infrastructure for their fleet vehicles. Is anybody else seeing things like that? Good, good. Hey, Tim. Hey, Tim.
Hey, good morning, everyone. I think this has been a really interesting conversation. I was just kind of listening in, but I just want to say that there's been some really good perspectives shared on the port side of things. I think we're going to this question number two. I really think what we're seeing is something where the either tenants or project partners, they're actually building the infrastructure up front because it's less painful to do so. So they're oversizing things. So the items that you would need, the switch gear we talk about, the transformers, everything else, they're sized for a full build out, but the actual chargers can be deployed at a later time. So you're building the pedestals, you're doing everything at once. And so to that end, this for question number two, one or two chargers doesn't make sense at a particular location, makes less sense because you're already under construction. And so the costs to build four or six aren't that much more. And so that's what we're seeing on our side of things. And even with the port tenants, knowing that deployments are for their truck fleet or even their equipment fleet, they're eventually going to have to convert to zero emissions. They're oversizing their infrastructure up front just so they don't have to go through that pain of having to reconstruct, purchase everything again, and there's the pain of doing that. And so that does speak to some of the perspectives that John had raised, timing wise. But the overall questions, those discussions are taking place now, just trying to determine what the upstream impacts are. Is it the 9 years? Maybe, maybe not. Is it less? Hopefully so. And so I just wanted to share those thoughts from the port side of things, what we're seeing with some of our trucking partners, what we're seeing with some of our attendants as well.
No, that's great. Good stuff. Good stuff. I'm Catherine. Um, and I think we'll,
Yes.
okay.
Yeah, sorry. I wanted to share that I know the Port of Long Beach um, shared with me a few years ago that there was a tenant that was putting in a bunch of truck chargers and that um, in the low utilization rate, they were going to be open to letting other fleets use their charging. I, I believe you were asking that, so I wanted to provide that information. And Leah Rao would be a good person to follow up with. I looked and I didn't see her attending the Zoom call right now.
And that was the Port of Long Beach, you said, right?
Yes.
That's great.
Yeah. Thank you so much for this. I'm sorry. I need to go to another
Yeah,
meeting.
thank you.
Bye-bye.
So Amber, I think you have the last comment here. So
Okay. Yeah, so when it comes to sharing chargers for like private facilities, it does get a little bit tricky because we did have one company that wanted to do that as part of like their grant for our clean truck fund. And they started after we awarded them, they started like kind of weaseling, trying to weasel out of it because they realized the logistics of it was kind of painful in that they couldn't. It's like if their facility is like has a gate, then they have to have
yeah,
all these new. So it depends on how closely related or how good the relationships are. Because again, these are all they're competitors for the same stuff. So it helps them in that it reduces their cost, but it also, if they have the relationship sour, then what is that company that was renting from them going to do later if
yeah,
they get kicked out? So
yeah,
it's a little like it's good in the short term, but it's not the best solution in the long run. There will need to be like actual real public charging. And then for question four, I think maybe for proposed stations, maybe there should be like a certain amount of completion done before you put proposed stations because there's a lot of, plans, but oftentimes it might, as we've already stated earlier, like it might take years and years, and then that's not very helpful for anyone really looking at the map. It's like, okay, let me look at what's available or what's coming soon. Oh, here's one. Oh, wait, that's gonna be done in 2035. So, and
yeah.
I need something now. So maybe like a percentage of completion if you're gonna, or where
Okay.
it's at. So that way people aren't gonna think, oh, we can rely on this in the future if I get a truck now.
Yeah, no, that's a good, yeah. And yeah, your point of the shared, you know, in some situations, it really is, it is kind of a bridge as opposed to okay, yeah, no, that's good. Good, good. Um, Let me just before Tim, let me just check time wise. Do we have other slides here? Or okay, yep. So Tim, well, you've got the last word here before we wrap up.
I was just gonna concur with what Amber just said. Yeah, that this sharing concept generally doesn't work. At least for our tenants, you're definitely not going to share with the terminal operators because you're just not going to charge trucks on a terminal property. But that being said, it gets very complicated when you have off-dock tenants wanting to charging infrastructure. Yeah, you start getting into subleases and everything else because all of a sudden you have high value assets parked there, and you have to determine responsibilities. What are the issues that come up? Well, what if something happens to that? or there's damage to something else. And so it gets real complex very quickly. So you're not seeing that so much on the tenant side of things, but where you are seeing this promotion is these service providers that you have out there, the Watt EVs of the world and forums are really pushing that depot concept and charging as a service. And so that's where you see that promotion and really encouraging these long-term contracts to use their charging network, their stations, and their facilities. And so just wanted to point out that sort of nuance there. I really agree with what Amber said.
Yeah, no, that's good. And what about the scenario of like uh somebody who may not have their own truck fleet, like IKEA, as they're receiving the goods, and if they had a charging infrastructure available to for the vehicles that get delivered to them, do you see that as a viable thing, or
I it, it's a more difficult one as you get further out beyond the boundaries of the port and those inland distribution areas. It's questionable because again, it can be a liability.
yeah,
Also, you have a very expensive asset, a station is damaged or a truck is damaged, then you start getting into the responsibility of who is responsible to make things right. And
yeah.
so, again, very expensive assets now all of a sudden, and it's a big risk for whoever's opening it up.
Great, great. Well, I really appreciate the dialogue. We're at time. I don't want to keep people late. We'll stay on for a second if there's other questions, comments. But please, let Nate know. His email's right here. If there's any feedback or suggestions for upcoming TAC meetings and things you want covered, or you have comments on what we talked about, again, we're always encouraging, folks to spread the word about our Advanced Technology Research Center, ATRC, and we'll follow up with the email summary to tech members. I'll hang on for a second if there's any other comments, but thanks everybody, and appreciate your time and input here. This is great. Thanks.
Oh, hi, this is Amber. I did want to add on to Tim's, like, it's
Okay. Okay.
unlikely that no one's like it's less likely that anyone's going to really want to fully charge their vehicle at like a warehouse. It'll probably be more opportunity charging because, the truck drivers and the companies get paid per trip. So why do I want to waste my time at a warehouse charging when I could be, doing more and more trips? So they'd want to try to charge near the end of the work shift or like when the shifts change rather than, in the middle of their trip, they're hauling.
Yeah. Yeah.
So that's just okay.
Yeah. No, that's yep. They make money by moving, right? Not by
Hmm.
sitting and charging.
Watson, this is Jonathan. It's funny you mentioned IKEA because we talked to one of their carriers that
Yeah.
they have a contract with, and they actually are running an electric truck from the ports up to their warehouse, um, just over the grapevine. And they said for now, it's just one truck, it's a pilot, but what they're seeing is that they can basically only do one run a day because they end up having to go over the grapevine. The time it takes to pick their stuff up, get back, they don't have enough range left to do additional runs, and I don't think they
Okay.
have the charging equipment set up over at the grapevine yet. That may not be true anymore, but when we spoke to them, they were having to go back to a local depot because it was a contracted service. It wasn't a IKEA's own truck.
Okay.
So there's also that sort of like dislocation of equipment with a lot of these contract carriers that, they may be servicing a customer, but they may not be able to use their charging equipment, right? And then they still have to go back to their own depot, which complicates
Oh,
it as
okay.
well.
Okay. Gotcha. Gotcha. That's a good point. Good point. Any other last comments there? Or insights? Really appreciate it. Thank you. Thank you.
Great. Thanks, everyone.
Thank you.
Okay.